everyone, we're going to find the limit as x approaches 2 for log base 4 of x squared minus 4, absolute value of x squared minus 4, minus log base 4 of absolute value of x minus x squared plus x minus 2. Now we're going to have to rewrite all of this because if you substitute in a 2 here, this is undefined. The domain for log is greater than 0. So basically, we're going to first simplify all this by condensing this using your properties of logs. So we're going to use the quotient rule, and this is going to be a single log base 4 of absolute value of x squared minus 4 divided by x absolute value of x minus square root x squared plus x minus 2. We still have this same issue. So what I'm going to do here is go ahead and multiply my denominator by the conjugate. So I'm going to do absolute value of x plus square root of x squared plus x minus 2. That means I also have to multiply my numerator by the absolute value of x plus square root of x squared plus x minus 2. And we're doing that because we know that a minus b times a plus b equals a squared minus b squared. In this case, this is your a here and this is your b here. So let's simplify that. This is going to give us the limit as x approaches 2 of log base 4 of, let's put this in parentheses, brackets. We're going to have an absolute value of x squared minus 4 times absolute value of x plus square root of x squared plus x minus 2, right, divided by, now I'm going to use this form here. So this is going to give me x, absolute value of x squared minus x squared plus x minus 2. Now the next slide, what I'm going to do is expand this and simplify my denominator. So that's going to give me the limit as x approaches 2 of log base 4. Now I'm going to do absolute value and expand that x minus 2 times x plus 2. And then we still had absolute value of x plus square root of x squared plus x minus 2. And the denominator, we had absolute value of x squared minus x squared plus x minus 2. So this is going to cancel, and then we have this negative, and you distribute the negative, and that's going to give you negative x plus 2. Now before we continue on, I want to show you something with this piece right here. If I take absolute value of x minus 2 times x plus 2 and divide it by absolute value of negative x plus 2, what I can do is multiply both of these by negative 1. So for the denominator, I would get absolute value. What the denominator would be x minus 2 if you distributed the negative. So that's what we'd have in the denominator. In the numerator, I can just say, well, then the absolute value of negative 1 is just 1. So that goes away. So what's going to happen is these two will cancel. So this is going to cancel with this based on what I just did there. So let's rewrite this as, we don't have a denominator anymore. We're going to write the limit as x approaches 2 of log base 4, and all I have is my numerator. And I can put it all together as absolute value of x plus 2 times x plus square root of x squared plus x minus 2. And put little parentheses there and finish that up there. All right. Now, let's see. I think at this point, we're good to go. Let's go ahead and take our limit. This is going to be log base 4. Then we have absolute value, substituting in our 2 for all these x's. We're going to get 4 times 2 plus square root of 2 squared plus 2 minus 2. All right, and what I've been doing is substituting in 2 for all of these. This is going to give you log base 4. All of this is going to equal 16. Now this equals log base 4 of 4 squared. Using your your power rule, we can move this 2 in front. This gives you 2 times log base 4 of 4, and log base 4 of 4 is 1. So we have 2 times 1 equals 2. So that is your limit. This equals 1. Thank you. Have a nice day. Bye-bye.